Well, hey there, everybody. Let's get a little homework help for tonight on our angled projectiles. All right. So here's our first question. We have a shell being fired from the ground. So let's draw ourselves the ground. It's going to be launched at an angle, and it's going to land on the ground because we haven't heard otherwise. So let's consider what we know here. They're telling us the initial speed of 1.68 times 10 to the third meters per second, pretty big. All right, and an angle of 35 degrees. Okay, first thing we want to do, horizontal range. Let's keep in mind what we're looking for here, delta x. And then amount of time the shell is in motion, so that means we're looking for total time. Let's keep that in mind as well. But our very, very first step, regardless, is that we need to break up that initial velocity into components. Because quite frankly, we are not going to use this giant number for anything except to find this stuff, right? We have a combination of both up and over when we fire a rocket like this. So you need to figure out the individual pieces in order to do that. So this one is going to be the opposite side. So you're going to take this and multiply it by the sine component of 35. For this one, you're going to use the cosine component. So there's our velocity, and we're going to use the, whoops, I just wrote it wrong, cosine of 35. All right, and we're going to work with those values. So my sine component, that one is, in this case, 963 or 964 meters per second, 1376 meters per second. And if you think about it, hopefully you understand why the x value is so much bigger than the y value, because the angle is below 45, so you have more going on in the horizontal direction. Okay, now let's put some graphs together. As we already know, the Vx does not change. In terms of the velocity, we have no acceleration in the x. The concept builders today did a great job of reinforcing that part. We are not going to put the value from the problem. Okay, yeah, there we go. Excuse me a minute. Let me cough a second. Sorry about that. So 1376 is our velocity in the x direction. Notice we're not using the 1.68 times 10 to the third. Once we do the trig, we never need that value again. All right, when we deal with the y, we start with a value of what, 963 meters per second. It goes up, it reaches a peak, it comes down. It's coming down to the same value, same space. Okay, at this point, we know that the velocity is 0. We also know that it's half the time, so it's half the total time. Okay, time to work with the y values because we know the most about them. So start with the 963 and work your way to the 0. The velocity is 0. We're going to use the slope of our line, negative 9.81 meters per second squared. All right, and let's see what we can figure out. So I don't know if I want to, well, I guess I'll go back up here. I got a little bit of space up here. All right, so negative 9.81 equals, all right, this is my initial velocity and my final velocity. So when my final velocity is 0, I have a shadow I keep contending with, so I keep blocking everything I need to see. That's why I'm hesitating here, because I can't see the numbers that I actually wrote down. Okay, this is going to give us time, and in this case, let's see, 963 divided by 9.81 is about 98 seconds in the air. I am rounding. Please remember, we don't round all that much. Let's face it, that's 98 seconds here. So to find this answer, part B, I just need to double that. So off I go. 196 seconds. That's the total time in the air. That's what I'm going to put up here. And then I can simply solve for the area. And that is going to be part A. So hopefully that makes some sense. Okay, now I cannot see how to change my screen to the next slide. So I am going to walk myself back to the computer and do it manually. That way I can maneuver. Just a minute. Okay. This one might look a little scary because it's like, wait a minute. I'm not starting on the ground and all that good stuff. So let's see how this one plays out. Let me work my way back. Okay. Artillery shell, initial velocity of 310 at 49 degrees above the horizontal. We're given time. You want to know the x and the y coordinates where it explodes relative to its firing point. Okay. So let's start with what we know how to do. So 49 degrees. I've got 310 meters per second at 49 degrees. So I'm going to do my sine and cosine piece again. Remember, cosine is for Vx. So 310 sine of 49, 310 cosine 49. All right, so I get about 234 meters per second. Again, don't overround. That's kind of a big deal. And there we go there. All right, so if I consider the x, and they tell you the time of what? 40 seconds. Okay, ta-da, solve for delta x. That's the answer to that one. And watch out for this, okay? I can't tell you how many people get the right answer, but then they have like put it in the wrong spot. You know what I'm saying? So be careful about that. Okay, now the y is a little bit trickier. Let me change colors and look at the y. The reason is you don't know where it is in the arc when you're at 40 seconds, right? So here's this thing, right? It gets launched, and we know, well, it's somewhere on the mountainside. So is it here? Is it here? Is it here? Did it land there before, right at the peak? I mean, we have no idea. We have no way of knowing. So the graph is a little weird. All right, what I will do is I'm just going to draw it kind of like that. Same deal. So that way I can use my information and kind of figure out what the heck is going on. Okay, so let's figure out, let's see, what was my value? 234. I'm going to figure out how much time elapses there. That's going to give me a great idea as to, you know, where we are, at least in terms of the arc. You know what I mean? So let's consider, let's consider slope. We know that the velocity here is 0, right? So negative 9.81 equals, again, this is my VF, so 0 minus 234 over t. Man, that's getting sloppier and sloppier. Hopefully you can read it. So when I do this math, I get roughly almost 24 seconds. So that means the peak of flight is at 24 seconds. So I'm somewhere over here, right? And I mean, to get to ground, it would be 50 seconds because that would double it. Well, I'm somewhere in between. I'm here. I'm on the way down, somewhere in there. Why is this important? Because it changes my graph for me just a little bit. So let's consider. This is to the peak of flight, right? And then I'm somewhere over here, but not quite all the way. See what I mean? So if we consider, I'm just going to work with hypotheticals here for a second. Let's say you did the math and for some reason this was 100. Right? That's 100 up. And I want to know its position, right? So it would be very helpful to know the area of this triangle. So let's say it was negative 25. Right? So it drops another 25. So the question then would be, well, where am I? If this is 25, that means I am at position 75. See what I did there? I took the top triangle and I subtracted the bottom triangle, and that gave me the Y position. That's what I suggest you do for this one. Okay, I'm not going to continue from here because we should have, wait a minute, it is a little more than that. So let me consider. Let me reconsider. Okay. we've got that triangle kind of in the bag. I'm going to erase the whole darn thing apparently because I just ruined it all. That's what I get for doing hypotheticals, right? So what did we say, 234? There it is. This is time. Let's just say 24. Since I'm not turning this in, I get to do that, right? And then we're somewhere over here, right? So 40 seconds here. So that means that this length is what, 16? Yeah, 16. That's good. I know the length of that part of the triangle, right? This part of the triangle is 24, and this height is 234. So my first triangle is easy. 1/2, 234, 24. So meters up. That's my altitude. That's how high I go. Okay, now I don't really know. I don't know the velocity down here. So I could use the slope of my line again to figure out the final velocity here because I need to know how long that leg of my triangle is. Okay, so negative 9.81 equals Vf minus Vi over Tf minus Ti. If I only focus on this, if I only focus on this bottom triangle, basically I'm kind of starting over here, right at the middle, right? So let's consider I'm looking for final velocity, and the initial velocity from this point here is 0. And the time that elapses, Tf minus T0, that's 16 seconds. It's about 157 meters per second. This is Vf. So this length right here is 157 meters per second. Now I can do the second triangle, for which I have completely run out of room, but I'll try to squish it in here on the bottom. So delta y2, 1/2, 16 for 16 seconds, 157. So that's what, 8 times 157? 1256. Okay, so now what I'm going to do is I'm going to take 2808 and I'm going to subtract 1256 meters. That should give me my final answer. That one's got a little more going on in terms of the y position, but we were definitely able to use our tools and figure it out with no trouble. All right, let's see if I can get it to switch. Nope, got to walk back to the computer again. All right, 1 second, last problem, and we will be good to go. Football kicked at ground level. How much later does it hit the ground? Oh, this one's going to be very easy, right? Because all I care about is time. And I saved the easy one for last, not even the toughest one for last. I saved the toughest one for the middle. That's how I like to roll. Oops, wait a minute. Sorry, my bad. Let's start here. 40 meters per second, 37-degree angle. I think we know what we have to do first, right? We have to do some trigonometry. I'm going to use the cosine function and find Vx. So I'm going to do 40 cosine of 37. Here I'm going to do 40 sine of 37. I'm going to get those components. Although to be honest, I don't think I'm going to need anything but the vertical to work with because we know the time in the air is dependent on the vertical stuff. So I'm actually going to be a little bit lazy. It's a little more than 24, but I'm just going to round. Okay, we know that time in the air is determined by the y because of the slope of the line, because of our acceleration due to gravity, right? So if this is 24 meters per second, I can find the time it takes to get to here. I think we see a theme, right? And then we can double it. in order to find the final time, which is how much later does it hit the ground. We're just looking for seconds. So it's a quick application of the slope formula yet again. We don't even care how high it goes this time. And so negative 9.81 t equals, so it's about 2.4 seconds here, which means for me, my answer is going to be 4.8 seconds. It's going to be the total. Hopefully all this helped out. I will talk to you tomorrow. Come find me if you need a hand. But drive slowly to school because the roads are supposed to be terrible. So make sure you're careful out there, people. And if you skid, just take your foot off the gas. Don't hit the brake.